In the previous example, we played around a little bit with the HTML5 canvas area. At this point, I'd like to sort of show you what I mean by play around with it, and actually spend some time with those other things that were mentioned. First of all, let's see where we left this off. I'm going to start with the very simple example we had created. So this actually begins up in the HTML. We create a canvas element right here. And with this element, we give it a particular ID, and we have to do that so that we can call it out in the JavaScript code where we actually work on the element. We also give it some dimensions, in this case 600 by 400 pixels. The last thing we do is we give it a background color of light gray. Here we're setting actually some CSS properties for it, and we'll learn more about that in the next section. Now, what actually happens here? Well, if you just looked at the HTML, it would look very boring. It's just a canvas, and a canvas really is just a blank space. Nothing's actually happening to it. Where we actually do something is down at the bottom here in this little JavaScript chunk. And so this is kind of a place where we grab the canvas, and we also have to get something called the canvas context, and then we draw there. And so we make a bunch of rectangles. And you may recall, here's what this looks like, this kind of wavy set of rectangles that makes an interesting pattern. So that's what we're getting right now. I wanted to make sure and just sort of reorient you to that. With that being said, let's take a look also a little bit at what's actually happening down here. Let's remind ourselves. So the first thing we do is we get the canvas tag. Remember, we gave it the ID rCanvas, so we can pull that out right here. We say get element by ID, and so we grab that and we save it to a variable so that we can do things with it later on. And currently we only do one thing with it in the very next line. We take that element and we do something called getting the context from it. The context is something that's commonly used when you're doing really drawing of any kind. It's just sort of, it's actually what we would call a state machine. It is the current state of all of the drawing values. I think one way to think about this is, what color of pencil are you currently holding? Where is that pencil positioned over the canvas? At what point? How is it rotated? What sort of options have you set? Are you going to draw dashed lines? Well, those lines have a little curved cap on the end. All kinds of things like that are represented by the context. And so when you grab that context, you're sort of storing all those. You're also going to use that context to give it instructions. Like we say here, grab the black pen. That's what this command essentially means. It says for the next stroke you're going to do, you need to do it in black. So theoretically here, we're going to grab the black pen and be holding that, so we're ready to draw with that. And then we get down here and we tell it to stroke a rectangle, which means outline a rectangle with the currently held pen, in this case a black pen. And we tell it several different things here. And let me put this into the comments so it's nice and clear. Draw rectangle at x, y of dimensions width, height. Or we'll say width by height. So here's the x value right here. Here's the y value right here. They're all separated by commas. And then the width is 200 and the height is 50. Let me go ahead and take this width down a bit, just for argument's sake, just to sort of see the difference here. And so that they don't go quite so long on the canvas, and see what that happens. So now these things are all shortened a little bit. It's still the same wavy pattern, but every rectangle is half the width it was a moment ago. So that's what we're telling it to do. It basically runs this script as soon as it encounters it. The browser starts receiving this information and immediately starts following the commands and rendering out the HTML as it's given. When it gets to the script tag, which is after it's already made the canvas, made the footer, it then executes that script tag, where it will grab the canvas element and start doing things with it. What I'd like to do now is play around with this a little bit, and the first thing I'd like to do is make this move. This is something we can do with a canvas that's actually really interesting. And actually, even before we make it move, actually, let's do one other thing first. Something you're going to see in the clock example that I sort of failed to mention here, but should be pretty easy to understand if you're coming at this from any sort of other programming language, but especially if you've done a little JavaScript before. We are going to need to define functions. Now, a function is always, in JavaScript, a function is always going to be some sort of name, like let's say draw wave of rectangles. And then it's going to be followed by a parameter list. And that list is always going to be inside of parentheses. Actually, more often than not, you'll find the parameter list is empty, but it's still there. This is essentially what a function is in just about any language, with a couple little variations here and there. But it's always represented first by a name, just like a variable name, and then by a list of parameters for that function. Now, very often in other languages, you would also need to list a type of any value that it would return back. So if it returned back an integer, you would say int, and that goes before the name. Or if it returned back a string, you'd say string. Since this is JavaScript and we don't have types, you might think, oh, well, we just need to say var. But in fact, there's a special keyword that we use in JavaScript. We don't really list the type that it returns because there are no types in JavaScript. Instead, we just say, hey, this is a function. We use the actual keyword function. And so that's all you really have to do. You start with the word function, so it knows, okay, now I'm defining a function. You give it a name and a parameter list. In this case, our parameter list is going to be empty. It's just going to execute some instructions. It doesn't need any values to do that. And then you have the body of the function. This is always represented by matching curly braces. You can do these like this. You can do them on the same line. It really doesn't matter. I think you'll often see me doing this, mostly because I've recognized that seems to be the habit of JavaScript programmers. Every language and set of programmers out there has their own preferences on where you put the curly brace, whether you put it on the next line or on the same line that you define the function. I'm going to go with the same line, but feel free to do your own just as long as you're consistent. That's the important thing. What are we going to put in here? I want to draw this wave of rectangles. Well, we're going to basically take these instructions that do that, and now I'm going to put them inside this function. And if you're lucky, like I just was there, Atom will actually recognize that it needs to move in an extra tab. So you'll notice it took all of this and actually pushed it out one more tab because it recognized it needed to do that. If not, you can highlight the whole thing like I did there. All I'm doing is holding down Shift while I press the up arrow key to get all those lines. And then you can press Tab to move it out or hold down Shift Tab to move it back. I think I've said that in a video before, but it bears repeating. It's a nice, handy little shortcut. So, I've moved these inside a function now. My first question is, will it draw the rectangles still? So think about that. Try and consciously sort of come up with the answer. If I go over and look at the page right now, I'm going to save it, will it actually draw those rectangles? We've moved them to a function, but otherwise we haven't changed the code at all. So what do you think? Yes or no? You can pause the video and try and work it out. But let's go ahead and see now. I'll come back over to the page here. Maybe. There it is. And let's refresh. No, it doesn't. Why? So what did we do? We changed this by taking those commands that were previously just sort of sitting out at what we would call the global level, I'm meaning not inside a function of any kind, and we moved them inside a function. And now they're not running. The commands from line 31 through 37 did not execute. We can pretty much be guaranteed of that because we don't see any rectangles around here at all. Now it's possible those rectangles were drawn somewhere where we couldn't see them. It is worth considering that, but I can tell you I can eliminate that possibility. I know for a fact lines 31 through 37 did not run. Now hopefully you know why. The reason is all we did was define this function. We said the function draw wave of rectangles takes no parameters, and here are the commands that are part of that function. We didn't actually execute the function. To execute it, somewhere in the code, we need to call it out by name. I always like to say all a function really is a collection of related instructions with an associated name so that you can call them by name rather than having to write those lines over and over again. So we could call this function many times by its name and it will execute these 8 lines of code for us, or 7 lines of code for us every time, with only one single function call. What does that look like? We just say draw wave of rectangles with a parentheses. As long as you don't have the word function on the front of it and you don't provide a body after it, you're telling it to call the function rather than to define it. Now this might feel a little bit weird. Technically here we're calling the function before we've defined it, but that's okay in JavaScript. In JavaScript the entire file gets parsed and identified once before it goes back and executes the global commands. every command that's at the global level here is going to be run. So starting from line 26 down to line 31 here, it will execute those lines. So that results in 27, 28, and 30 running. The lines from 32 through 39 here, or 40, these are actually at the scope of this function, draw a wave of rectangles. So they wouldn't get run unless we call the function, which is happening at line 30. Let's save this and go see now. There, our rectangles have come back. So hopefully that all makes sense. We're not trying to do anything particularly complicated here. I just wanted you to think about it and think about what's going on and start thinking about functions, because really JavaScript, it is a procedural programming language, we say, and a procedure is just another name for a function. So we defined a procedure here, and then here we call that procedure. And again, recognize order is not important in JavaScript. Now it is in many other languages. C++, as long as you're not inside a class, order matters, as does, well, Java is always inside a class, so Java you can get away with it. And C in particular, it very much matters. Order is very important. And there's many other language where it is, but JavaScript it's not. All right, so now we can do this drawing with a single line of code. We're just going to call this. What I'd like to do now is to play with this a little bit. I'd like to modify our wave of rectangles so that instead of just always drawing the same, we have a way to quote-unquote offset that wave of rectangles. Now before we do that, let's think a little bit about exactly what's happening here. I'm going to separate this out onto multiple lines. As long as you do that around commas, you can always separate out a function call like this. So the first thing that we have right here is the actual x, y location of the rectangle. And then right here, we have the width and the height of the rectangle. That's what we're ultimately doing here. I'm going to get these to line up a little bit. There we go. So here's x right here. We have it such that x always starts at 10 out, and then we move the triangles to the right by I times 10. And what's I? Well, that's just our loop variable. I is going to slowly change from 0 to 40 as this loop runs. And so you're going to draw 40 rectangles at 0, 1, 2, 3. And so that's just going to keep adding 10. This basically creates rectangles at x equals, let's put this in comments here, x equals first 10, then 20, then 30, then 40, and so on and so forth, out to, I guess, 400, right? I guess 410 would be the last one. No, we're strictly less, so yeah, it would go out to 400. So it's going to draw rectangles all the way out to 400. What about the y values? Well, the y values are a little more complicated here, of course. The very first time around, it's going to take, what do we have here, 100, and then it's going to add on a sign. It's going to take the sign of I divided by 4. Here's a little trick. You don't have to pull out your graphic calculators anymore. You can just Google graph sine of x. And you can put in fairly simple formulas, and Google will do that for you. And so here it is. Here's the sine of x. We kind of want to see it from 0 here. So from 0, 0, it first goes up and over, then it comes down and up, and it goes back and forth like that. It's that standard kind of oscillating function back and forth. And we want to try and make our picture do that. That's exactly what it's doing. It's moving in this fun sine wave motion. That was the only reason I picked that. So the y value is going to slowly fluctuate from 100 plus the sine. Initially, I will be 0. So the sine of 0. What is the sine of 0? Well, a lot of people know this off the top of their head, but the sine of 0 is itself 0. So the very first value is going to be 100. Then it's going to move on forward, and slowly it's going to take values that will go up, or in our case, let's see, because we're offset a little bit, they go down because, remember, our y-axis is inverted, so it goes down until it reaches 1 right here. But it's always going to be offset by 50, so it's going to go down to 50 or 150, then it's going to come back to 100, And it's going to come back to 50 because it goes negative for a while, and then it's going to go back to 100, and it's just going to keep moving back and forth in that motion because we use math.sine. Now the precise values here are not as important, just understanding that this is what sine does. It's going to move in a curve down to 150, then back up to 100, all the way up to negative 50, or excuse me, all the way up to just 50, subtracting off 50, then back to 100 again. 100 is the center because of this. We're always adding 100 to it. That's why we get that fun kind of wavy motion. And then width and height, that should be self-explanatory. That's just the dimensions of the rectangle. So hopefully that makes sense, what we're doing there. It's just a fun function to play with when you're trying to draw using math. There's lots of those. That's one that's essentially pretty easy to just pull out and do something with. Right now we start at 0, because I starts at 0. But what if I were to start at pi? Or pi over 2, or something like that. Pi over 2 is 45 degrees, or is 90 degrees. Pi over 4 is 45 degrees. What if we were to sort of offset it like that? Let's give ourselves a parameter here when we define this function. We'll say angle offset. This is now a variable that comes in. Again, note, I don't need any var here. I don't need any int or type like that because JavaScript doesn't have it. Basically, we just list the name of the variable we'd like to take in, and this is now a parameter of our function. And I'm going to actually use this right here. I'm going to just add angle offset. And so this is going to offset every value that we're drawing, as if it were starting, instead of at an angle of 0, at some other angle around the circle. Then I can pass that in when I actually call the function. So let's start out by passing in math.pi, capital P, capital I, divided by 4, 45 degrees. Offset the whole thing by 45 degrees. I haven't drawn that yet. So far I'm looking at the old one. Now let's refresh. Look at that. The whole thing sort of shifted down a little bit, or up. The whole wave seemed to shift to the side a little bit. Let's do pi over 2. There we go, it shifted a little more. Pi itself, let's do 1.5 times pi. And then the final 2 pi. And 2 pi is like 360 degrees. It's all the way around the circle. And at that point we've come around full circle. So now we've created this version of the function that we can provide to it an offset that will cause the wave of rectangles to draw slightly differently. I do have a goal here, of course. You'll have to bear with me. Why do we do this? Well, again, let's look at it like this. First, let's give it a 0. In fact, here's what we're going to do. Let's duplicate this. 0, pi over 4, pi over 2, 3 pi over 4 will do, and then a full pi, so pi over 2. So if we send in 0, we get this, essentially what we have when we send in nothing at all. Let's try the next one. It all shifts forward just a little bit. Shifts forward again. Think like an animation person. Think about frames of an animation that we're creating here. Shifts forward a little bit. Basically, our little string of rectangles here is doing the worm. Kind of looks like a worm trying to inch along, right? That's the idea. By being able to draw these slightly offset from one another, that's what we achieve. And so on and so forth. We'll leave it at that. You get the idea. So it's not a very compelling animation when I have to go and uncomment a line, refresh, do all of this manually. What I want to show you here is how I can make it automatically redraw frames and animate. There's lots of different ways to do this. Or I should say, there's really 2 different ways I can make it automatically do an animation. First, I'll show you the one that's going to match the clock example, which is a perfectly valid way to do it. Here's what we want to do. Let's create a little function called draw next frame. We won't give it any parameters, but what we're basically going to want to do is have a variable of some kind that keeps track of what our current ratio is. So we'll call it ratio, and say it equals initially 0.0. When we call draw next frame, what we want to do is we want to draw the wave of rectangles using ratio times math.py. And so the first time it would be this, the next time it might be 1/4, then 1/2, then 3/4, and so on and so forth, just moving in that general direction. So once we've drawn it once with ratio, we want to move ratio forward to the next value. Now, I could do it 1/4 at a time, but all the animation people out there know, well, that's not going to look very smooth, right? Let's make it a little smaller. Let's add to ratio 0.05, let's say. This is a fairly small amount that we're adding to it, and that's how much we want it to move forward each frame. And let's just let ratio keep moving forward like that. This should basically give us this effect, only with much more fine-grained steps. And we're going to shoot for an animation that's maybe like, well, why don't we do it really slow at first, right? We'll do 0.25, and we'll just create a really slow animation so that it matches what we're doing down here exactly. I'm going to go ahead and delete these commands now, because draw next frame is doing the same thing. However, notice that we've lost any sense of repetition here. It calls it once, it advanced ratio, but it doesn't call itself again. Here's what we're going to do. We're going to set it up so that this function is called repeatedly at regular intervals. And this is done very easily in JavaScript. We say setInterval, and for this, we give it the name of the function we want it to call. Draw next frame. Now we only give it the name of the function we want it to call. We're not calling the function itself, so we're not going to put the parentheses on that. We just say call draw next frame. And then the question becomes, how often do we want to call it? Basically, we give it an interval, however many milliseconds should go by before it calls it again. Here, we probably want to do about 1/4 of a second. There's 1,000 milliseconds here in every second, so let's say 250. So we'll let 250 milliseconds go by. That's a lot. This is like 4 frames per second we're doing here. So this is very slow, but that's why we're moving by 1/4 of a pi every time. So this says, call the function draw next frame every 250 milliseconds. It will keep doing this over and over again. Voila, animation. Let's see what we get. Oh, I broke it. Now we take a look at some debugging. So let me go ahead and inspect element here, see if I can get any sort of error. You'll learn a lot more about debugging JavaScript down the road. But anytime something like this happens where it's clearly not working, do inspect element, and that brings you into the developer tools. I'm in Safari, so this might look a little bit different from what you see in Java, or excuse me, in Chrome. And in fact, let's avoid any confusion here. Let's do this in Chrome. By and large, the only reason you'll ever see me in Safari is because it's the default on a Mac. I have nothing against Chrome at all, other than the fact that it's not working on my computer for some reason. Interesting. Let's just solve this. Okay. Notice here this big red 1. That means I've got an error. Usually you want to find the console. There'll be something similar. And make sure that you have everything enabled, all or something like that. So it's saying unexpected token at line 33. Of course. I do this all the time. I forgot to tell it that this is a function. Draw next frame is a function. I always forget to put that on the front of my function names. There we go. Hopefully that's all that we had that was a problem. Let's try this. Oh, wow, that is funky. Not quite what I had in mind, but it's close. So what did I forget to do here? This is something that we often take for granted. When we start drawing, we assume that our canvas is blank. It's not. It's going to have the contents of whatever we drew before, and if we want it to become blank, we have to blank it out ourselves. Luckily, there's a really easy way to do this. So, right here where we say draw next frame, before we draw the wave of rectangles, we need to clear the previous frame. The easiest way to do that is to say ctx, take our context, dot clear rect. And then we just tell it the dimensions that we want it to clear. We want it to clear everything. So we'll say 0, 0 to canvas.width, canvas.height. The canvas.width, canvas.height is the full dimensions of our canvas. Let's try this again. There we go. There's a very jerky, sloppy worm going on here, but not bad. So there's our crude, slow animation. Let's take this up a notch. Something that's a little more reasonable might be about drawing a frame every 30 milliseconds. That's 33 is actually getting close to 30 frames per second. And we can get down to 15 is 60 frames per second. But we're going to have to slow our ratio way down, because if we're calling it that often, our worm's going to be going crazy. So let's fix that. Let's say 0.05, see if that's slow enough. Oh, that's a little fast still. Let's make it slower even. Let's try 0.3. There we go. Oh, it creates this kind of crazy effect in my eyes. I see all this flashing going on, but you get the idea. That's what we're getting here. Something that's a little more reasonable, I usually like to do about 30 frames per second, so I'll do that. There we go. That's a little easier on the eyes. So there we go. There's our little crude animation that we created of our little rectangles walking along in the worm. Again, exactly what's happening here. We tell it to run draw next frame every 30th of a second, and so it'll keep calling this function. We're advancing our ratio forward every time. So we're taking some ratio of pi, some little slice of the circle pi, and moving that far forward in our sine function every time, because we pass that in as a parameter here. And we get some really simple information or animation out of this. Now this is similar to how they do it with the clock function, only you'll find that they do this at a much grosser rate, because they only want to see the second-hand tick every second. So they do every 1,000 milliseconds, because in theory that's the only time you need to change it. Of course, part of your homework is going to be to make it look smoother. So one of the things you'll need to do is take that set interval and make it smaller. In fact, in the world of JavaScript in the browser, there's a much better way to do this. Let's take a look at what that might be. Ultimately here, they have a function that's designed specifically for animation. setInterval could really be used for any function that you want to call repeatedly, and you get to decide how often it gets called. But animation is actually a lot more difficult than that. When you try and animate something, the amount of time that goes by before you're able to animate it again varies. It depends on how hard the computer was working on other things when you're trying to draw it. And when more or less time goes by during that interval, you need to respect that. Now we're not going to get too deep into that here. That's actually a pretty intense thing from the world of computer graphics, how you deal with variable time where not each frame goes by at the same amount of time. But we can use the functions that are designed for it. It's called request animation frame. This is a built-in function to JavaScript. And just like setInterval, all we have to do is tell it what the function is that draws the animation frame. In our case, it's draw next frame. Really, there's only one difference between request animation frame, well, two differences, I should say. Two differences between request animation frame and setInterval. The first is you don't get to specify a time. It assumes that you're trying to do smooth animation, and it will attempt to call it, it will attempt to call your animation frames every 60th of a second. So it tries to shoot for 60 frames per second. This is a built-in constant that's defined by the W3C and is ultimately ideal for smooth animation. The other thing it doesn't do, this, as the name suggests, does one single animation frame. It will not keep calling this function because it wants to give you the flexibility. Maybe you don't need to animate. Maybe you want to call different functions every time you animate. Most of the time, at least when you're doing simple stuff, you do just want to keep calling the same function. To achieve that, you go inside the function itself, draw next frame, and at the very end, we're going to repeat this line. This creates an internal loop. The first time we call request animation frame, draw next frame, it then comes down, draws it, and then it ends up setting up itself to call again. And over and over and over again. It will just keep calling itself basically infinitely, which is what we want. Here we don't have to specify a time variable because request animation frame gates it for animation. This is really the ideal way to do it when what you're doing is animation, rather than using setInterval manually. It's a small change, but it's an important one. If we come back over here and refresh this, it's going to go faster now because we were at 30 frames per second. Here now it's back to 60. But this is still the sort of ideal way to handle animation when you're doing JavaScript.